So let's talk about the technological foundation. First of all, we have a solid, time-tested proof of stake. You'll see in the news so much talk about, Ethereum merging, moving to proof of stake. It's this big accomplishment. We launched with proof of stake on day one in 2018, and we had a working proof of stake, and it's been working since there. It's been working for 4 years, and we've had something like 99.99% uptime. Now, it's hard to define uptime for a blockchain, right? Because it's chunky. You get the blocks. So the way you can define it is you look for any interval between blocks where you have a more than the minimal interval, and you count that as downtime. So by that metric, we've had exceptional uptime. And the few times where we've had downtimes are basically transition periods around protocols. Very high decentralization. There's more than 405 bakers. Another thing that's important is that we've never, in the Tezos protocol, gave any incentive for people to split their stake, which means that when you look at the number of bakers, you get something that's somewhat reliable. Like we know that some bakers have more than one address, but by and large, this is a number that reflects the number of participants in our community. It's not there's no cap on the amount that a baker can have in order to try to artificially inflate the number. There's also no limitation on the number of bakers. That's one aspect that's tricky to get right with proof of stake, and that we did. So there's a minimum stake, which is 6,000 TEZ. So just based on that, you could say, well, there's 6,000 TEZ, there's 900 million TEZ. So you can only have 150,000 plus bakers, but in practice, that's a larger number than the number of people who are maybe interested at any given time in being a baker. Minimal hardware requirement, which is quite important for decentralization. And that does not affect just bakers, it affects also any node who wants to validate the chain. You can still validate the Tezos blockchain on a Raspberry Pi 4, and I think that's quite stunning that you can do that, especially given that we'll see a little later. We still tease a lot of performance out of this node, and in terms of decentralization as well, the proof of stake model we have is one that's based on delegation. It's not delegated proof of stake, it's liquid proof of stake, so you can move your delegation around, and 75% of all TEZ are actually delegated, so 75% of the addresses, of the TEZ which are in existence in the network actually takes the time to go and find a baker, and that participates in the governance, that participates in decentralization of the network. So we have a really robust base with proof of stake, and we were a pioneer in this space. Under the hood, what powers it? I would say a focus on security from the beginning. So the functional programming, Camel, I think has been quite helpful for us. I tend to say this slide used to be called. I worked with some ecosystem on the slides who've been super helpful in putting this together. And I remember the slide at first was called just like, design through a camel. And I worry about that. I love OCaml as a language. It's been fantastic for us. I think there's a perception that Tezos is all about OCaml sometimes. And so people will say, oh, you have to write OCaml for writing your smart contract. And, OCaml is a fantastic tool, but it is a tool. Tezos is not OCaml. OCaml is not Tezos, obviously. But it's a tool that's worked great for us because it lets us write predictable code. It lets us, not have to worry about memory errors, memory corruption. There's entire classes of bugs that we don't have to worry about because we're writing in OCaml. It makes it easy to test. It makes the code actually quite readable. And these are benefits that we have in the core protocol that have allowed us to actually iterate quite rapidly on how the core protocol can move. I think with other languages, we wouldn't necessarily have the same level of agility. And the same could be said of Michelson. It's strongly typed and statically typed. It's functional. So a lot of these properties that make it robust, readable, amenable to analysis are also true of the virtual machine for Tezos. So we're used to evolving. There's been a lot of upgrades. These are just the most recent ones. So Jakarta, we started with transaction optimistic rollups. They're optimistic rollups that can only do transactions for now, but generic optimistic rollups are coming in the next protocol proposals. Ithaca had a hot swap of the consensus algorithm. We started out with this chain-based proof of stake consensus algorithm called EMI. And EMI was based on, there was a long line of proof of stake algorithms that were basically trying to replicate the Nakamoto consensus in proof of stake. We departed from that and we implemented something closer to a classical BFT. I think this is a model that has proven its strengths in the Cosmos ecosystem. However, in Cosmos, there's a bound on number of validators. What we did with Standard Bake was basically remove this bound so you can have as many active validators as you want in a system. And the way we do that is by randomly sorting, getting a selection of bakers to participate. And so, we were able to hot swap the consensus algorithm. That's something that doesn't really happen in blockchain. It's something that Ethereum has been trying to do for 6 years. Hangzhou. So Hangzhou had smart contract views. Sorry about that. That was a very long-standing request from developers. It took us a while to get there, but we did get there in optimizing DApp development. And in Granada, Granada was one of our performance improvement proposal where we had 3 to 6x, depending on your contract, performance improvement in the gas consumption of contracts. And this is still well running on a Raspberry Pi. What I'd like to say is that when you think of the Tezos governance model, a lot of it, I would say the impetus for it is the need to upgrade while retaining consensus on what constitutes legitimate upgrade. You don't want to have someone be the source of legitimacy for an upgrade. It has to be validated. But as a side effect of building this, just purely as a side effect of having this governance procedure, a lot of the Tezos code base was built to make it easy to upgrade. And as a result, just because we were focused on governance early on, we have an architecture that's quite modular and quite easy to upgrade compared to the upgrade process that other chains have to go through. So in terms of the upgradability, this is how a lot of engineering gets done. If you see a complex system working, in general, it was never built out of thin air. It was always built on top of a less complex system, which was built on top of a less complex system. And this is what we've been able to do through this governance model and ability to upgrade. It's just upgrade step by step by step by step, and progressively get where we want, while also getting information and understanding better about how to build the systems and how the systems work as we build them and as they grow. So today, there's 8 globally coordinated development efforts that go into most of the proposals that you see. Nomadic Labs, of course, in Paris here is an important entity in pushing forward these proposals, but they're not the work of a single team. And every single time you'll see a blog post announcing proposals, you'll see all the teams which are involved. In general, Trilitech, Marigold, Functory, and DiLambda, Terides. So there's a lot of teams participating in this. We've had 10 successful upgrades in the past 4 years. So if you look at the average, that's 1 every 4 months. But it's because in the first few years, we didn't have them as often as we do now. Now we're on a cadence of about 1 every 2 to 3 months. So we've accelerated quite a bit since then. And so I would expect that in the next 4 years, we were not going to have 10 successful upgrades, but more like 16. So rapid evolution. What did we get out of this governance model? Well, we cut the gas cost by 75% in Delphi in 2020, and then interpreter optimization in Granada cut it by another 75%, and then we cut that for contracts that can get cash, popular contract, by about 30%. So we've improved a lot just by picking low-hanging fruits on the mainnet, the performance of our contracts. Now, to be honest, one of the reasons we were able to do that is because when Tezos launched, it launched with conservative parameters, right? The idea was that we didn't want the chain to blow up in anyone's face. We didn't want the chain to go down. We wanted the chain to be solid. We didn't want to launch something that wasn't going to work. Once we got more confident it was working, we were able to release some of these parameters and optimize others. Some of them were written in a very robust manner, which would give us a lot of comfort that they would work reliably when launched. Once this was launched, once this was working, you can focus on optimization, you can focus on making it better. So we're working, and we're going to talk about scaling and scalability. We're working on that, but I would say there's still a focus also on optimizing the layer one and picking low-hanging fruit and making it easier and faster to do transactions just on the layer one. So we have new features now coming. Transaction optimistic rollup, I mentioned. So they're optimistic rollup that focus now solely on transaction, but transaction is still a huge use case for the Tezos chain. We have a ton of transaction happening every day. I would love to see bakers, for example, start using transaction optimistic rollup to try and pay the delegates. That would be an interesting use case. Right now, I would say our blocks are not full. So because the blocks are not full, the fees are absolutely minimal. So there's not a huge impetus to use these scaling solutions. But I think they're quite important because a lot of new applications come and the first question they ask is say, look, this is great, the fees are very low, but if I become very, very big, how am I going to fit on your chain? And being able to have these features, being able to go to these people, go to these projects and dApps and say, look, if you come, will have the capacity to host your volume is quite important. We've had liquidity baking in 2021, which was a neat way to provide liquidity for TEZ against Bitcoin on the blockchain. And I think it was a first among layer ones. It's a small experiment. It's small in size, but it's worked over time. And Tenderbake, which I've already mentioned, where we hot swap the consensus. So we're continuously optimizing L1 and introducing new features, making it easier to use, better for developers, and while at the same time working heavily on layer 2 solutions. So the point. Okay, so why do we get on-chain governance again? Because that is a key part of Tezos. So first is that it involves the community in the protocol upgrades. And this is a conservative procedure, right? You need an 80% supermajority. And we have quorums around 50%. So this requires a high level of participation and a high level of agreement. So we don't go out and say like, oh, here's a hard fork, here's a new version, it's better. Because if we did this, the thing is, it would probably work. We could go out and say, Nomadic Labs could go out and say, like, here's a hard fork, here's a new version, here's a feature. And then what do you do if you disagree with it? Well, if you disagree with it, you can choose to keep on the old version, but probably most people are going to just fork because not necessarily because they agree, but because they think everyone else is going to. And you get into this beauty contest dynamic, which don't really work. It's not a form of governance. And this is real. This is not a rubber stamp. So, the first proposal for Ithaca was rejected, and largely because the parameters are so conservative. There was massive agreement in favor, but despite that, there were some dissenting voices, and as a result, it was rejected. Were the voices right? No. But is it good to demonstrate that the governance is real? Yes. So high legitimacy, I think, is quite important. It lowers the risk of forks. It also means when you tokenize things that you have some clarity onto what constitutes a main chain. Again, we haven't seen major forks in smart contract platforms recently, but when they do happen, you have an interesting question, which is if you have a stablecoin, which is like a tokenized bank account, well, who is which fork should they honor if someone tries to redeem something? If you have an NFT, even if it's purely digital, you have a piece of art. Now it exists on two chains. Which one is the real one? Which one is not the real one? That's an interesting question. At least we have a clear answer with a governance procedure. It also means that because there's a schedule, you don't have to wonder, oh well, is this hard fork going to work or not? Developers know what's coming and they can plan for it. Okay, so the developer tooling. The developer tooling is quite important. I've talked about the core foundations of the protocol, but I would say equally important is being able to easily build things on this protocol. And advanced developer tooling is something that happened quite late in the ecosystem, if I'm being frank. I would say we started getting good tools in late 2019, and early 2020 is when it started picking up. And then it got really much better, I would say, in like late 2020 and through 2021. So there are many languages in the Tezos ecosystem. I think one of the downside of working with a lot of engineers who like programming language theory is that everyone wants to create a programming language. So the three dominant ones today are SmartPy, which has the syntax of Python. And if you squint, you think you're writing Python, but you're actually doing metaprogramming of SmartML in Python. But it's quite it's been quite popular, and a lot of Python people love using it. It also has a really nice built-in testing framework, which I think has been one of its strengths and point. We have LIGO, which is LIGO. It basically when people tell me like, oh yeah, Tezos is this thing where like you have to write your smart contracts in OCaml, and I say no, that's not true. That's not true. Tezos is written in OCaml, and then you don't have to use and Mikkelsen is typed and such, but you write it in a high-level language like LIGO, which looks like OCaml. But no, there's different syntaxes for LIGO, and you have JS LIGO, for example, which is JavaScript-like. Yes, you have ML LIGO, which is like OCaml, because it is a good language. So many syntaxes, and one of the features that I really like in LIGO that is quite useful and very poorly known is mutation testing. And I would really encourage everyone who's writing smart contract to try out mutation testing. So the idea of mutation testing is the following. It's very simple, but very powerful. You have your smart contract, and you have your test suites, because of course, you wrote unit tests for your smart contract, right? So you have your test suites, you have your smart contract, you run your tests. Okay, they pass. Now, what mutation testing does is that it's going to randomly change one thing in your contract. Maybe it will change a plus into a minus. Maybe it's going to change a 0 into a 1, or a if x into a if not x. And then it runs your test. And if your tests still pass, even though you change the code of your smart contract, you have a problem, right? Your test shouldn't pass. Like, there's something fundamental that you've changed about the logic of your contract, and your test didn't detect that. So it's a way of testing it's a way of checking that you're really testing all the corner cases. It is excellent at making sure that you're testing for, like the corner effects, off by one errors, all of these things. Very, very good. And today, most of the smart contract bugs that I've seen, not talking about like reentrancy bug or this type of things, but most of the smart contract bugs that I've seen in terms of the logic of the contract, can 100% be caught by mutation testing. The benefit of it, I would say, it's not as powerful in a sense as doing formal verification of your contract, of course. But if you draw a curve and say like how powerful is this tool in terms of catching bugs versus like how complicated it is to use, it is that simple to use, and it is really, really strong at catching bugs. So I think more people should do that when they write smart contracts. And we have archetype, with an emphasis on business logic, which can let you write complicated contracts very succinctly, easier to specify and formally verify. It's been a rising star now and getting more and more popular. Large developer toolbox, and there's a few logos here. I'm missing a lot of logos, of course, so it's been a top priority since launch. It was hard to get the ball rolling on developer tooling. I'll tell you why it's been a top priority. Back in 2017, I was in the Silicon Valley. I met with people from Y Combinator, and I was saying like, oh, what can we do, and so on and so forth. And they say, I'll give you one advice: invest in developer tools because they compound. And I was like, that is a great idea. We'll invest in developer tools. And then things happened. But we are now investing a lot in developer tooling. So. Xeon is probably number one right now in developer tooling, just by the sheer size of the ecosystem. But I would say we're number two in terms of what's available. So there's a variety of Tezos wallets, first of all. So Kukai, which has been a great onboarding tool with the social login through the web. Temple, many more. The Beacon wallet connector SDK, I think, was a very big milestone into making it easier to write dApps. So you have Jeff in the audience today if you want to ask questions. No, sorry, that's my bad. That's Takito. We're talking about Beacon. Beacon was built by Paper. So Beacon is our way of connecting all the wallets. So instead of, if you're writing a dApp and you want to connect to a wallet, you don't want to write a specific script for connecting to every wallet. So you connect to Beacon, and then Beacon sends a message to any wallet, whether or not the wallet is on your computer, whether or not the wallet is on your phone, anywhere else. There's a similar mechanism called Wallet Connect, but Wallet Connect was Ethereum specific. Interestingly, now we have Wallet Connect 2, which is open and which is multi-chain. So perhaps in the future, we'll see some form of merging between Beacon and Wallet Connect 2, which would, I think, enable a lot more wallets to connect to the Tezos ecosystem. We have the tech area. So now, here's Jeff. Framework for dApp development. So it's plugin based. You can use it to create scaffolding for your contracts, imports packages, run test networks, deploy your contract, try your contract on a local sandbox, try your contract on a test network. As a developer, it's a very useful tool if you want to be building this. What's missing here is Taquito. So Taquito, you have the logo here, is a library that you can use in your browser that will let you connect. That will let you connect to a Tezos node, get all the information, parse all the messages. So it's, the Taquito and Beacon stack is what you will use on your dApp front end, and Taqueria is what you're going to use on the back end in order to build your project. Lots of block and smart contract explorers, which also double as indexers with useful APIs like TZ Stats, TZKT, and Better Call Dev. Indexers. We have DeepDupe based on TZKT, which will let you index part of the state that are relevant for your dApp. Kepasa, which was built by TZConnect. And then, last but not least, SDK libraries for integration with application in JavaScript, TypeScript, Python, Go, .NET, you name it. We had libraries for mobile integration in iOS and Android super early on for Tezos. I think in 2019, we didn't call it the Tezos mobile stack, but we had the libraries. Now, let's talk about scaling. So in 2017, I proposed ZK rollups, and basically I have this blog post from 2017 where I said, look, this whole sharding approach for Ethereum is not going to work. This is way too complicated. This is underspecified. It's not clear that this whole thing is workable. Here's how you can do it. And I described an approach which is now popularized as ZK rollup. I think there's a better way now. Now ZK rollup is super popular. You'll see it with, of course, with the Stockware products. You'll see it with Aztec. You'll see it with all of the, with ZK Sync. You'll see it with the products coming out of Polygon. They're all doing ZK rollups, and there's a lot to like about ZK rollups. But I've come to prefer optimistic rollup for this, and I explain why. So first of all, what is a rollup? So a rollup is a separation between the execution layer and the transaction ordering layer. So in a rollup, you post your transactions or batches of transactions onto the main chain. And then you have some specialized nodes which are tasked with eating those transactions in, computing an effect on the state, and then posting assertions as to what the state is. So in a ZK rollup, what you'll say is oh, well, if we've taken in all the transactions that have happened, this is a current state. And by the way, here's a cryptographic proof that this assertion is correct. It's nice. The issue is that verifying this proof is very fast. It's super neat, but it's extremely expensive to compute this proof. You can do it quickly, because you can parallelize. So yeah, in theory, if you have a cluster of 10,000 computers, they can take in all these transactions and compute the proof quickly. But it's tough. If you have 10,000 seconds worth of computation, trying to do this in 10,000 computers and then get everything back into a single one is still very, very tricky. And it's still very expensive. Like the cost of running all these provers is quite high. Now, in an optimistic rollup, you do pretty much the same thing, except you don't prove anything. You just post your assertion that, hey, this is that's the state. And then people can comment and people can dispute it. So people can say, look, I don't believe this is actually correct. And then you have a dispute. And in that dispute, you're going to have some binary search to try to find at which point in the execution you disagree. It's kind of like debugging a program. If you've debugged a program, you get the wrong answer, and you're like, well, something went wrong somewhere. Let's try in the middle to see if I get the right state. No, okay, I get the right state in the middle, so the error is a little below. or the error was above. So by doing this procedure on chain, you can actually dispute it. Now, the benefit with an optimistic rollup is that you don't have to compute the proofs. So your optimistic rollup can go really, really fast. That's a huge benefit. You're not limited by the speed of your proofs. The downside is that you have more complexity. In some sense, you have more complexity because instead of shoving all the complexity into building these cryptographic proofs, and then you have a simple verifier on chain, now the complexity is on chain because you have a complicated state machine of like who's disputing what, who's proving what. That's the number one problem with optimistic rollup. The number two problem is censorship. So if the active validators, the block producers of your network, conspire to censor transactions with a ZK rollup, not much happens. You cannot use it. Your funds are frozen, which can be bad, but that's it is what it is, and maybe you'll find some other way of restarting the network. In an optimistic rollup, if the validators decide to censor your transaction, then in principle they could make a fake commitment, and then you wouldn't be able to dispute it. You wouldn't be able to come in and say, this is fake. So you can't have this dispute. So they're less resilient to censorship. Overall, if you look at the trade-off, I think the trade-off is still massively in favor of optimistic rollup. And the reason for that is you pay no penalty, and the downside is only in a scenario where you basically have a majority of your validators who are trying to conspire to steal money from the rollup. Like I'm not talking 1/3, I'm talking about 2/3. You have 2/3 of your validators who are trying to conspire. And this is why in Tezos, when we're building optimistic rollups, they have a 2-week window for withdrawal. The reason being, if you get into a scenario where you have 2/3 of the network that is trying to conspire to do something about it, you have 2 weeks to figure it out. You have 2 weeks to hard fork out of a situation like this. So in some sense, the benefit is very strong for the optimistic rollup. The thing I like about them also is that they combine horizontal and vertical scaling. So what do I mean by that? Horizontal scaling is you can have many rollups and you'll have a different person validate every rollup. So that's great because we don't have the situation where everyone has to validate everyone. You create your rollup and validate it, I create my rollup and validate it. That's it. You just need one honest validator per rollup. So that's horizontal scaling. Now the problem with horizontal scaling is that it doesn't compose very well, right? If you have your contract in one rollup and your contract in another rollup, they can communicate. They'll communicate through the main chain, but it's going to be slow. It's going to be cumbersome. If you listen to the Solana people, they will tell you like, "Oh, we're all about composability. Isn't it great? We have just one giant big state machine, and when it works, you can actually have all these contracts call each other." But you can do that with rollups, and that's the beauty of it. Because you only need one honest node, it's okay to have really, really high requirement on that node. If you want the requirement to run a rollup to be that you're going to have a machine that needs, I don't know, like 256 gigs of RAM, and it's 8 CPUs, which each with 32 cores. Why not? Like, you don't want to do that for your consensus, right? You don't want to do that for your consensus because you want everyone to be able to take part in the consensus. So having the consensus run on a Raspberry Pi is important because you want to have an honest majority. So since you care a lot more about decentralization for the consensus, because decentralization protects you. It protects you against reorganization. It protects you against censorship. So very, very important to keep your layer 1 as decentralized as possible. But for the execution, it's a very different model. It's not honest majority. It's a single honest member. And if all you require is a single honest member, you can have really, really high hardware requirements. And in fact, even if you wanted to build a high throughput blockchain, even if you didn't care about horizontal scaling at all, the right way to build a chain like this is not to build high vertical scaling on the layer 1. You build a layer 1 and then you build a single rollup which does all the vertical scaling. So this is great because you basically get a lot of performance without sacrificing decentralization. And Shrine Rollup is the way we're doing it. So we're not the first people to do rollups. There are rollups on Ethereum, in particular Arbitrum, which is probably one of the best designs out there live on Ethereum. It's more decentralized in principle, their design is more decentralized than Optimism. In practice, all of these rollups that you see on Ethereum are still controlled by a multi-sig because they want to be able to upgrade their contract. So Unshrined Rollup, the difference is that instead of building it as a smart contract, it's built as part of the protocol itself. Now, why would we do this? Why go through the trouble of changing the entire protocol as opposed to just creating a smart contract? There's a few benefits. One is that it's a lot more efficient in terms of gas and storage because we don't have to run this through an interpreter, so it runs natively on your machine. It can be highly decentralized. So by that, I mean, it's not going to be controlled by a smart contract, which means, if we want to upgrade features, we can do that through the governance procedure. So we don't have this dilemma of saying like, oh, can this upgrade versus, do we have some sort of multi-sig control over it? It can benefit from new protocol feature. We're also building a data availability sampling, so they can be upgraded. They can get better over time. And they can be defended by validators, and that's, I would say, a very important. That's a very important part. If we see if you see, for example, censorship happening. So you had an invalid commitment to Rollup, and you have censorship, but it's not coming from the validators. It's coming from just someone spamming the mempool. So I'll have someone say, I'll buy the entire gas content of every blocks to prevent a rejection from happening. If this happens on a smart contract, bakers can go and say, like, that's not my problem. That's the smart contract. Whereas if it's an enshrined rollup, no, it's part of the protocol. Then I would say it changes the contract between the bakers and the community. The idea is that, no, you actually have to defend it. It's part of the protocol. It's not just a smart contract. If this happens, you actually have to make sure that you're going to prioritize instructions for rejecting invalid commitments over other instructions in mempool. So this prioritization of transaction is, I think, a big feature of enshrined rollup, which removes some of the, I would say, the sensitivity to censorship downside. So the transaction optimistic rollup just launched in Jakarta, which activated a few weeks ago. So next generation of optimistic rollup on Tezos is a lot more than just smart contracts. They've been called smart contract optimistic rollup because they support smart contracts, but they do a lot more than that. So when the transaction optimistic rollup were built, they were built with a simple system where you can do a rejection in just one step. If someone makes an invalid commitment, you can do a simple proof that immediately proves it doesn't work. That doesn't generalize very well to having more complex computation because there's too many steps. So we have the interactive proofs that I talked about, and it can do general computation. This smart contract optimistic rollups, they run a assembly kernel. So they run WASM, for example. So any program that you can compile to WASM, and anything you write in Rust, Go, or C++, you can. Or assembly script you can easily compile to WASM. So anything you can compile to WASM, you can just run. You can load it as if you were loading an application, and it will just run on a chain. And the beauty of it is that when you run your rollup node, you don't even have to run it in WASM. You can run it natively. You can compile your Rust natively, run your rollup node, run your program, and you only have to run the WASM compiled version if and when there's a dispute, which in principle doesn't happen because no one has an incentive to actually make an invalid commitment because they'll be caught and they'll lose money. So you can go extremely fast. This is what I really want to impress upon everyone. You can write a program, compile it for your with no overhead. There's no overhead of gas metering or anything like that. You just write your program, compile it, and there you have. You can load it as a rollup. So. Among the programs we can compile as a rollup, by the way, is Go Ethereum. You can take Go Ethereum, compile it to WASM, and then load it into a rollup, and there you go. You have an Ethereum chain running as a rollup on Tezos chain. It takes a little more than that. So you have to look a little bit at how you interact between layer 1 and layer 2, how you make transfers in and out. No, but by and large, you can really reuse I would say 90% of the code base of any blockchain and run it as a rollup. So the turbo, how do we make them any better? So when you look at rollups, you outsource the computation. So now the nice bakers with the Raspberry Pi don't have to compute the effective transaction. That's great. They still have to download all the transactions. They still have to look at the mempool and download every single transaction to include them into the main chain. Now that's much better, right? Especially if you're talking about transaction, you might say, well, executing a transaction versus downloading it, maybe it's not a huge gain. That's why we compress transactions a lot into transaction rollups. Like we compress them down to 12 bytes. But if you have a computation, then all of a sudden now it's a big difference. Like running an expensive computation is a lot more than just downloading the inputs to that computation. But still, you have to download everything. It's a problem. So the approach to that, and we by no means did not invent data availability sampling. It's something that's been discovered and rediscovered many times in the space, but we're actually implementing it. So it's a data layer that's going to be dedicated to rollups. And so any rollup can consume its data, its transactions, either from the main chain or from this data layer. So it removes the storage and bandwidth bottleneck, because essentially what the bakers do is that instead of downloading all of the transaction data, they download a small shard of the transaction data. And the canonical way in which you do this basically is that you take all of your data, you put it into a big blob, you turn the blob into an error correcting code, and then everyone, whether it's the bakers or the validators, download a small portion of this. And if everyone successfully downloads a small portion of it, everyone is convinced that the data is actually here, and you can actually recover it by going to these people and combining it. So the gain you get by having rollup and data availability sampling is about 1,000x to 10,000x. So right now we're around 200,000 transactions. We're on 200 transactions per second. So you get to about 200,000 to million. At this point, you have other things that start breaking. Like you can scale like this in principle, but at this point, you have to worry about how are indexers going to work with this? How are wallets going to handle this? How are block explorers? So there's all the challenges that come. When you deal with throughputs, you have to think of a pipe, and the throughput of a pipe is always going to be the narrowest section. But at least as far as the protocol is concerned, this is how you get there. You can go to these numbers, by the way, just on back of the napkin. If you think of a transaction, you can compress a transaction down to roughly 12 bytes, especially if you aggregate signatures. So you take your aggregated signatures, take your aggregated transactions, 12 bytes. Now, 12 bytes, 1,000 transaction is going to be, a million transactions, is going to be 12 megabytes. If you want a million transactions per second, that's 12 megabytes per second. That's 100 megabit per second, which, is reasonable. That's without data availability sampling. That's just if you ask every baker to have 100 megabit per second, which I think is excessive, by the way. Even if you have 100 megabit at home, it doesn't mean that you're actually getting this 24/7 at every point, like at peak capacity. So if you're counting on bakers having like maybe 1 megabit per second connection, and then you have many bakers, then it gets better. And that's the thing that's really, really cool about this. It scales with the number of bakers, right? When you have data sampling like this, the work that every validator has to do is proportional to their stake. So if I'm a huge baker, I'm going to need to download a lot of things because I'm going to have a lot of endorsements. So I need to download a lot of pieces. If I'm a small baker, I don't need a lot of bandwidth. Okay, so Tezos is, on heel of all this, Tezos is going fast. If you look at social engagements, Lunar Crush has some good numbers. We're constantly in the top 5. We've been having 6 million contract calls month over month. There was massive growth throughout of 2021. And we started, I would say, 2021 or end of 2020 at around 100,000 smart contract calls. I like to measure this as opposed to transactions because we've always had a high number of transactions, partly because bakers are paying delegates, and also transactions can also be just indicative of like if there's a lot of speculating or trading activities that will raise the number of transactions, but it doesn't really give you an indication of usage and adoption, whereas interaction with smart contracts are more meaningful in this respect. It was also a sign that all the tooling and all the wallets, all these parts of the ecosystem were finally ready for people to actually use dApps on the Tezos chain. There's 700 new deployment of dApps month over month, 2.4 million funded accounts. One thing to say about the funding account, it still costs quite a bit of money to create an address on Tezos. It's not cheap. There's a technical reason for that. The reason is that Tezos takes care of state bloat, and it has from the very beginning. We charge for state consumption independently of charging for gas, which is the right thing to do. But as a result, you have to pay some amount for creating an account. So people don't just go and create thousands of accounts just for fun. And these are funded, so these are accounts who actually have TEZ in their balance. NFTs, of course, have been one of the biggest engine of growth for the Tezos chain, but it keeps going on its heels. Just very recently, the TEZ hackathon had 11,000 developers sign up. It's a passionate community of builders and users, and I worry every single time someone puts a companies on a slide like this, because we can't put everyone. And these are big names in the Tezos ecosystem. There are other names who are also great and also big, and in spirit they're all on these slides. So it's grassroots driven, definitely, and very very DIY in terms of the NFT community. And I think this is something that has it's not artificial, it's organic, and it's something that's driven a lot of real growth and a lot of visibility as well. Arts and culture are tastemaker, and they influence a lot of people, and I think that's quite that's something that works in a very strong in our favor. Everyone's enthusiastic, eager to help. We've also had the true Web3 story on Tezos with the birth, death, and revival of hic&nunc.xyz. So for those who don't know, hic&nunc was one of the biggest NFT platform, not just on Tezos. It was the biggest on Tezos, but it was one of the biggest in the world. And the developer, Raphael, behind it, at some point decided, you know what, I'm displeased with it, I've had enough. And he decided to pull the plug on the website. But what's interesting is that the website was pure Web3. So it was an open source code base. All of the NFTs were on chain, and all of the metadata were on IPFS. So, it was a real deal. And as a result, it took about an hour for people to work together to resurrect the website. So before that, you'll hear this like, what's the point of Web3? Well, if you had a private company and you did this thing, and maybe they would cut your access, and maybe they would do that, and you can make up an example, or you can go to a real example. This is great. This is exactly what happened. Like artists spent some time building communities there and putting their art there, but it wasn't lost. It lives now in Teya, in Object.com, and in a bunch of other reincarnations. So yeah, I think this is a great story. And by the way, in terms of this, like, I'm going to give you a real example as opposed to a made-up example. We've seen one with DeFi. So there's been a lot of large lenders in trouble, some blowing up, like Celsius, for example, blew up. BlockFi apparently was close to blowing up. The protocols we haven't had trouble have been the DeFi protocol. I mean real DeFi, right? I don't mean like Luna Ponzi stuff, but like MakerDAO, Compound, Aave, all of these protocols have fared extremely well. So as opposed to telling the story of saying like, oh, well, if you have an intermediary, maybe they go and make an insecure loan. Nah, you can point to an example. So I like that we can point to a real Web3 example with hic&nunc. Thank you for the Halfsoul, who's one of the most ardent Tezos supporter on Twitter, for listing all these Tezos Git repos. It's a work of wonders. He's led 880 Git repos who have been active in the last 12 months. Number 4 right now in Lunar's Crush social mention and engagement rankings. This was the Electric Capital and BofA Global Research, and by number of number of repos when the report came out, we're actually right behind Ethereum and slightly above Polkadot. So there's a lot of it's very good because in some sense we have like one of the highest social media activity. We have some of the highest developer activity. We're somehow still not quite a part of the blockchain and crypto zeitgeist that exists between other projects. And one of my goals for the next year is to be more of a part of that zeitgeist. It's not enough to have success and adoption in a corner. I think we want to be. It should be known that it's a case. Active and vibrant community. I like these tweets. I read almost every tweet about Tezos, by the way. I think I spend too much time on Twitter. But I have the hashtag Twitter, and I go and I scroll. It's tough now because there's just so many which are about NFTs, which aren't directly about Tezos. They're just hashtag Tezos. But when you see things like Tezos has the best community in crypto, or awesome work from the crypto community, all of that, this is always balm to my heart. So very happy to see this type of things, and it's very active, very positive, very vibrant, and I think that's quite attractive and a very good reason to build on Tezos. So supporting the Tezos ecosystem, we have 8 actually 8+ core development teams working on developers. In the extended ecosystems, there's over 100 full-time engineers. We've mentioned 405 active validators. There's grants, investments, hackathons and events. Lots of opportunities for developers to get into the ecosystem, get support, and build on this growing platform. All right. Thank you. I have no idea how I did on time because I didn't have the prompts, but I'll take some questions now.
We have time for about 5 minutes of questions, so raise your hand. Mike will come to you.
Yes, let's see you for 1, 2.
Hello. Oh. Do you hear me?
Yeah,
okay.
I can hear you.
Yeah, thank you very much for the introduction. I have a question. What do you think Tezos should focus on or be famous for in the future? Because if we look at other blockchains, for instance, Polygon apparently wants to focus on gaming very much as one of their focus areas, as well as Solana, gaming, and Polkadot probably more like UN and governmental stuff. And you mentioned that Tezos is, of course, famous for NFTs, but I don't know, do you want to explore more DeFi or focus on gaming too, or what should be the area of, or do art NFTs?
Yeah, absolutely. So in terms of like areas of focus for adoption, I tend to I want to focus on things that I think are going to work and I think are going to have some staying power, which is why I love art NFT. Because first of all, art NFT may be not the biggest portion of NFTs today. It depends whether or not you count like a lot of the PFP collections as art or not. We're not going to get into the question of what is art. We know it's painting of horses, but I know this is a use case that just makes sense. Like people are going to keep making digital art. It's not going to change. People are going to want to keep collecting it, and it's either going to be on a database or a blockchain. And I think it's going to keep being on a blockchain. So for me, this use case is very solid and also culturally relevant. The other one that I see is gaming. So yes, Solana wants to do gaming, and Polygon wants to do gaming. I'll mention, there's only one top-tier gaming studio last year that did something with a blockchain, and it was Ubisoft with Tezos. Actually, it was Ubisoft, and it was EVE Online also with Tezos. So for all the news that you see about Solana and Polygon around gaming and all of the excitement, we actually got real integrations happening in this ecosystem. So yes, gaming is very important. The Tezos Foundation does sponsor two gaming teams. Esports team who are involved in building experiences for their users and for game developers. So I think we're going to see some interesting things in this area. I think the thing with gaming is basically that everyone is looking at is saying, like, first you have some product market fit because they have been digital economies for the longest time. So people are used to trading digital goods and digital currency in games far before they were any cryptocurrencies. That's number one. And number two is that a mediocre game has more daily active users than one of the top blockchain. So it's like if you can make this transition and say like, hey, if you can have conversions, even like low conversion number would be huge for blockchains. I would say scalability is super important here. When you see blockchain games and you see like, oh, they have 5,000, 10,000 daily active users, like some of the most successful ones have these levels, it's still very, very low. And the reason is, well, could it be lack of interest in the game? Because some of these are not really games. They are, like gambling vehicles where you're just going to grind and get some yield reward until the yield runs out. That's one thing. But also the fact that they don't scale. So, who's going to build a game for millions of people if as soon as they connect to the blockchain is going to, crap out, which is why building these scaling things is so important if you want to be able to host tons of games. And I think proofs on ZK rollups, as much as I love ZK technology, are not going to cut it for the type of scale that you want for massive games. And in DeFi, so I love financial engineering. I think we need to grow in DeFi in Tezos. When people criticize the adoption of Tezos, oftentimes they want to say like, there's not enough DeFi activity. So we definitely want to grow in this area. I think one potential source of strength is that Tezos has been a big blockchain for STOs. You don't hear that much about it, but there's billions of assets which are tokenized on Tezos as STOs. The value prop of an STO is there, like as an issuer. It's nice. You don't have, it simplifies your cap table, it simplifies transfers. But the value prop becomes far more interesting if you can plug this into lending protocols, into trading protocols. We're not the only ones looking at this type of use case, but I think we have a good base for actually deploying it. So yeah, I would say that those are the biggest area. Arts and collectibles, gaming, DeFi specifically with an eye towards DeFi that finances actual thing as opposed to other DeFi projects.
What would you tell them, like in the context of their projects?
That's a great question. So yes, I think the cost is going to go down, first of all, for the ZK rollup, but it's never going to go down to the point where you're not like taking a performance hit. Like right now, I think you're talking about 3-4 orders of magnitude slower than actually running the thing, which is a huge cost if you want to run throughputs on the millions of tens of millions of transactions per second. So could it go down? Yes, but I don't think we're going to ever be much better than 2 orders of magnitude. Even if you start building custom hardware or all of these things, it's still going to be like a noticeable hit. Now, it could be the case that, no application, all combined application on blockchain only need about 100,000 transactions per second or something like that. And, like that's the market for it. And as a result, because competition gets a lot cheaper, all of a sudden you don't really care that you're paying for one. So that's possible. And by the way, we have some ZK rollups like in the works on Tezos. So it's not a lack of interest on my part. I would bet more on the optimistic rollup, but I also like to make multiple bets. So there's definitely a bet going on the ZK rollups. But I do see I just think that even if the costs go down, it's still going to be quite an impediment. Oh, and sorry, there was another part to your question.
ZK Sync and Starkware.
Oh, ZK Sync and Starkware. What does the public miss about them? Well, I think if you ask the public, about ZK Sync and Starkware, they will say what? Because so I don't know if we mean the public or like the public that's attending blockchain conferences or such. I would say one thing that they miss is that a lot of the time when people talk about compiling EVM code, for example, to circuits, what they mean is a single contract, not a chain where people can deploy contracts that are going to interact with each other. In one case, you're building a compiler from EVM to a circuit. In the other case, you're building an interpreter of EVM inside a circuit, which is a harder problem. But I think what makes a lot of the value of blockchain is, the whole money Lego saying and composition. You're kind of removing that composition if you are just doing one contract inside of Rollup. That's the first thing that they miss. Second thing they miss is that a lot of the time, these things work with a data availability committee, and there's a lot of trust that's being put into this committee. So if the committee signers decide to not reveal the data, they cannot steal, but they can hold your data hostage as long as they want, which I think limits the security of the system. And oftentimes those provers are highly centralized. It's not possible for everyone to run a prover. Sometimes, quite often, actually, the provers are closed source. So you'll have an open source prover that's very, very slow, and then a closed source prover that's fast. So I would say those are the main thing that people are missing about it.